guys, we're going to be working on the section that's on tangents. All we know so far is that if a line is tangent to a circle, it's going to hit the circle at exactly one point and it will end up creating a right angle with the radius. So looking at what we have here is it asks, is AB tangent to circle P? If AB is tangent to circle P, it would create this 90-degree angle. We're going to check to see if this is an actual true statement. I'm given a right triangle here. To check if it's a right triangle, we already learned we're going to be using c squared equals a squared plus b squared. So my c would be 17. So I'm going to do 17 squared equals 8 squared plus 15 squared. 17 squared gives me 289 equals 64 plus 225. Just keep going down. Let's see, 289 equals 289. Is that a true statement? Yes. So what do we actually know? Is it tangent? Yes. Moving on to this next one. This is kind of the introduction of where this section gets a little bit tricky at times, is the fact that it asks if it's tangent. Okay, so this should create a 90-degree angle here because it should be perpendicular. Do you guys see how this 5 here is laying on this part? It doesn't mean that 5 is the full length. It just means that 5 is here. A lot of the times they'll put something like this if they mean the whole part, or it will just only have one section to work with, so it will put the number. So over here, this part is just 5. How do we find this part? Well, that would represent the radius. We already have the length of the radius here. So this is 11, so this would also be 11. So let's see, this triangle, I have 11, 14, and in this case, 16. So let's check to see if this works. So I have my c squared equals a squared plus b squared. If it's tangent, c squared, so I have 16 squared equals 11 squared plus 14 squared. 16 squared gives me 256 equals 121 plus 196. And I get 256 is equal to 317. That is not a true statement. So, is it tangent? The answer here is no. Okay, so moving on to this next problem. What we have here is we're already told that JK is going to be tangent to this circle L. Therefore, I can make this 90-degree angle because that's what happens with the radius and this tangent. So I'm going to set this up and say, okay, well, x is my full hypotenuse, so I can do c squared equals 7 squared plus 19 squared. In this case, you get x squared is equal to 410. I'm going to square root both sides, and I get x is equal to 20.2, and that is my answer for x, which is down there. Moving on to the next ones that we have here. Number 4, same kind of deal when it comes to what they're actually giving. So I know already this is a right angle. I have x is this full length, 11 is this full length, but 7, it's not saying it's the full length here, so it's just that little part. What is this length over here? Same here, so this is going to be 11. So what I have here is a length of 18, and in this case, that's actually my hypotenuse. So I'm going to do c squared, so 18 squared equals x squared plus 11 squared. 18 squared is going to be 324 equals x squared plus 121. Subtracting off 121, subtracting off 121. Here, I get x squared equals 203. I'm going to square root both sides. I get x equals 14.2, and that is my answer for right now. Hi guys, we're gonna actually go through number 5 that has 2 different ways that you can solve this. Pretty much what we have is going off of all of the other problems. We know we can add the right angle there. This part here is 10. This part is just x. It doesn't tell us it's the first full part. So this is also gonna be 10. We can add those together. Technically, this is represented as x plus 10. That's going to be one way I show you how to solve this, is if you use this length as x plus 10. The first way is going to be the easier way of solving this specific problem. What we're going to do is, instead of putting x plus 10 here, I'm going to just say the whole entire length is y. Okay, and I'm going to go solve for y. Once I solve for y, all I have to do is subtract off 10 to get my value for x. So looking at this, what I can set up is my c squared, so y squared equals 24 squared plus 10 squared. Y squared is equal to 676. Square root both sides. I get y is equal to 26. So this entire length is 26. I know that if this whole thing is 26 and this little part is 10, I can subtract it off. So I'm going to do 26 minus 10, which is equal to 16, and that's going to be my x. So I'm going to throw it down here as 16. I just want to show you the other way that we could solve this, saying if I left it as x plus 10, okay? So this one I'm going to be leaving it as x plus 10, and we're going to see what we can do with this. So this is my right angle. This is still my hypotenuse, so that's my c. So I'm going to have here, I'm going to say x plus 10 squared equals 10 squared plus 24 squared. Over here, we know because there's addition in here, I can't just put the squared with both. So I need to write this out twice. So I get x plus 10 equals, we know this from the other problem, this gives us 676. So I'm going to distribute by foiling. I get x squared plus 10x plus 10x plus 100 equals 676. My x squared isn't going to cancel out, nor is my x's. So this one ends up using factoring. If I know I'm going to have to factor, I'm going to move this to the other side. So I'm going to subtract off 676, subtract off 676. I get x squared plus 20x minus 576 equals 0. Now I go and I make my little t-chart that helps me figure out how to factor. So I have to find 2 numbers that multiply to negative 576 and add to 20. So I just go ahead and start dividing this by numbers to see which numbers do work. In this case, it's 36 and 16. It's either gonna be, because this is a negative, it's either gonna be negative 36 and positive 16, or positive 36 and negative 16. But we need it to add up to 20. So the one that's going to add up to a positive 20 is this second option here. So I go back into my problem and I split it up. I say x plus 36, x minus 16. Because these are multiplied equal to 0, I can break this off. And I can say x plus 36 equals 0, x minus 16 equals 0. I'm going to subtract 36, x equals negative 36, add 16, I get x equals positive 16. I look at here, this is slightly questionable. I wonder if this is going to work in my problem. I look into my problem, it's not. This length is not going to be a negative 36. So that one is not going to work. 16, however, will, and that's my answer. And if you look, the last problem, got the exact same answer. It was just a quicker process. Moving on to number 6. I have a right angle here. 25 is the full length here. This is x. 11 doesn't tell me it's the full length, so I'm only assuming that this is 11. So this length is also radius, so that's 11, making this full thing here 22. I'm going to set up my problem using the Pythagorean theorem. I have 25 squared equals x squared plus 22 squared. In this case, I get 25 squared is going to be 625 equals x squared plus 484. Subtract off 484, subtract off 484. I get x squared equals 141. I'm going to square root both sides. I get x is equal to 11.87. I'm going to put that over here as my answer. Okay, moving on to number 7, what we have is we just still have JK tangent, so I'm going to create my right angle here. This is 6.4, this whole thing is x. However, this 3.5, we can't assume it's the whole thing. We're assuming it's this little part. So if this part is 3.5, the radius over here also has to be 3.5. So I'm going to add the two together to get 7. And I'm going to start my equation, my hypotenuse. So I get x squared equals 7 squared plus 6.4 squared. I get x squared equals 89.96. I'm going to square root both sides. I get x equal to 9.48. And that's my answer here. Number 8 actually is just like number 5 in the sense that there's two main ways that you can complete it. I'm going to show you this one real quick. I still have my right angle here. This is 25. This is 7. This little part is x. Each is going to be x. So I'm going to label that also as x. Now technically, x plus x equals 2x. However, I'm just going to call it y for the time being. And then once I find y, I can just divide it by 2 to get my x. So if I do it this way, what I'm going to have here is 25 squared equals 7 squared plus y squared. I have 625 equals 49 plus y squared. Subtract 49 from both sides. I get y squared equals 576. Square root, square root. I get y equals 24. This whole thing is 24. Each of the parts is the same, so I'm going to take 24. I'm going to divide it by 2, and I get 12, which is going to be my value of x. So I get x equals 12. Now, had we just kept it at 2x, I want to show you what that would look like. So this would be 2x. Gonna set it up with my right angle here. I get 25 squared equals 7 squared plus 2x squared. Make sure that you keep this in the parentheses. So 25 squared is going to give me 625 equals 49 plus. Now there's no addition or subtraction in here, so my squared can go to both. I have 4x squared. Let me get this to the other side. Here I have 4x squared equals 576. Divide by 4. I get x squared equals 144. Square root, square root. I get x equals 12. That one you didn't have to do the divided by 2 because you just were finding x. So these are 12. So those are the two ways that you could have done that exact same problem. Okay, so the last one in this part of the section is going to be one where we can't just rewrite it as y, and I'll show you why in a minute. So I have x here, that's the full length, 20 here, that's the full length, 10, it didn't say it's the full length, and there's more than one section here, so we can only assume that it's this part. This is x, the radii should be the same. Had I just called this y, I would try to set up the equation and I would have, okay, y squared equals x squared plus 20 squared. This is going to give us an issue because I'm working now with y's and x's. We're not going to be able to find a solution here with what we know. So instead, I'm going to have to leave this as x plus 10 because this part is x, this part is 10, and I'm just adding them. This way, when I plug it into my Pythagorean theorem, I'm only using one variable. So that's my hypotenuse. I get x plus 10 squared equals x squared plus 20 squared. Over here, yet again, there's an addition sign in there. I cannot just simply square each. So instead, I'm going to write this out and FOIL it. Okay, so looking at this, I have my x squared plus 10x plus 10x plus 100 equals x squared plus 400. I can combine my 10x's here. I get x squared plus 20x plus 100 equals x squared plus 400. This one ends up being pretty cool because it looks like you're gonna end up having to factor, but you don't. And the reason why is, let me move my x squared to the other side. Cancels out over here, but it also cancels out over here, leaving me with just 20x plus 100 equals 400. So I'm just left with 1x. Let's get it by itself. I'm gonna subtract off 100. I get 20x equals 300, and I'm going to divide 20 on both sides. And when I do this, I get x equals 15. And that is going to be my answer. Okay, so what we get from the notes is if they look tangent, just assume they're tangent. So for example, BC appears to be tangent, so it is. This is going to create a 90-degree angle with the radius here. One way or another, what we're actually told in that last property is if two segments from the same external point are tangent to a circle, then they are congruent. So what I know is that this and this are both going to be congruent because they are tangent to the same circle. So all I need to know is let's just set them equal because they are congruent lengths. I'm going to subtract 5x from both sides. I get 3x minus 19 equals 23. Add 19, add 19. I get 3x equals 42. Divide by 3, divide by 3. I get x equals 14, and that's what they wanted. So that is my answer. Number 11, very, very similar. Yes, they appear to be tangent, so I'm allowed to assume they're tangent as of the instructions. So what I know is that this and this are going to be congruent lengths. Therefore, they have the same measurement. So I'm going to set them equal. Really, the only difference in here is they didn't actually want x. They want you to go ahead at the end and plug it in because they wanted PQ here. Okay, so we have 5 equals 6x minus 13 plus 13 plus 13. I get 6x equals 18. Divide by 6, I get x equals 3. Yet again, we want PQ. PQ is this length right here, so I'm going to plug it into here. So I get 14x minus 13 is equal to 14 times my x, which is 3 minus 13, and that's equal to 29. 29. This is the length. It doesn't actually give me any units here, but please make sure you're not putting degrees with this. Okay, so number 12, yet again, we can still assume the same. I can set those two equal to each other. I have 10x minus 41 equals 4x plus 7. Subtract 4x, subtract 4x. I get 6x minus 41 equals 7. I'm going to add 41, add 41. I get 6x equals 48, and I'm going to divide each by 6 to get x equals 8. So the thing about this is they don't actually want the value of x. It's great that we solved for it because we know we're probably going to need it. However, they actually want to know what the length of SV is. I might call that for right now y. So let's say this whole part here is y. Okay, well, what I know is these are right angles. I apologize with my drawing. Doesn't really look great, but these are right angles. Let me look. I have right triangles on each side. I have this is 17. I also know this is 17. What I'm going to end up doing is I actually just have to go and use the Pythagorean theorem to solve for my SV, which is what I actually want. We're leaving it as y. So I might use this right triangle down here. I get y squared equals 17 squared plus, well, I don't know this length yet. Let me go ahead and plug it in with my x equal to 8 to get the length of over here. When I do that, I get 4 times 8 plus 7, and that's going to give me an answer of 39. So I'm going to put 39 here. Well, now I can plug this in. 39 squared. I get y squared equals 1,810. Let's square root both sides. I get y equals 42.5, and that is my SV. Therefore, that is my answer on this one. Okay, so looking at this, what happens is we kind of get a similar property that we've seen before, where if this is 11, this is also 11. If this is 16, this is also 16. This is 9.5. This is also going to be 9.5. So what they actually want is find the perimeter of triangle DEF. So I look, DEF is the whole triangle. So I just need to add all of these up. So the perimeter, I might say 2 times 11, because there's 2 of them, plus 2 times 16, plus 2 times 9.5. And I get the perimeter equal to 73. That's my answer. This one ends up being a little tricky. It's kind of a cool problem. We're going to see what we can do with this. So far, I'm going to start with what I have. This whole length is 37.5. I can't just divide it by 2. We don't know if that's a true statement. However, I look over here. This part is 23. So I also know that this part is 23. Okay? Now, what I know is that this part is 23. The whole part is 37.5. And we don't know this part. We've learned that we can subtract the 2 to get the missing little part, which is going to be 14.5. If this is 14.5, this is also 14.5. If this is 27.1, this is also 27.1. We can do the same over here. I don't have either. I don't have a full length, but I do over here. If this is 52.5 and this is 27.1, I'm going to subtract them to get 25.4. This is going to be 25.4. Now what they actually want is the perimeter of the quadrilateral. By the way, quadrilateral, four-sided polygon. So that's this shape, so I'm just gonna add them up. I already know this full length, so I'm gonna say 37.5 plus, I know this full length, 52.5 plus these ones, 23 plus 25.4 plus 14.5 plus 27.1. So many the ways that you could do that. You could have just done 2 times these, 2 times these, 2 times these, 2 times these, and added them all together. One way or another, you get a total of 180. That's a length. Make sure you don't put degrees. And that's us done with this section.